Hello, everybody. Thank you very much for your time, for your presence, attending this roadshow. My name is Hector Marin. I'm with Qualcomm, and we are going to talk about 5G as expected. But the interesting part is that we will present all what we have behind the 5G developments, and that is why we think that all roads lead to Qualcomm. Let's start. The idea is that I'm going to present one part, and my colleague Milene, out of the Brazilian office, is going to present the second part, but we are facing some technical difficulties, so chances are that I will present both parts. But let's see if we can fix that while we are going through this presentation. Next, let's start with the first slide. Thank you very much. And this is just the introduction. What is our view on 5G? Basically, very quickly, Qualcomm. Who is Qualcomm? Qualcomm is a company that we do develop technology. We are behind a major developments on the mobile technologies, starting on 3G, and obviously major developments on 4G, and we have a big presence in 5G. And the reason of that is because we have invested more than 61 billion US dollars in our lifetime. This is a huge amount of money, excuse me, that we have been investing, and as you can see, in the different paths on this technology, meaning on the evolution of the technology from the year 1995, when we introduced the CDMA concept to the world, to the industry, and then the latest developments that we have today in 5G. Next slide, please. Now, 5G. We have been talking about 5G, and 5G is a lot of things, but the important part, and I'm trying to focus on this because the different presentations we are explaining what is 5G, the economic impact of this technology. And as you can see here, according to the Ericsson Mobility Report from this year, it is expected that the mobile traffic is going to grow 5 times from 2019 to 2025. So a huge growth that we'll have. And it means that and this is interesting, the monthly, every month, the mobile data traffic in the year 2025 is going to be 164 billion gigabytes of information. And as you can see, this is a huge amount of data that is going to be transmitted in the year 2025. And 75% of that traffic is expected to be the creation and consumption of multimedia. So this is going to be a key aspect in this life. And also, in that year, it is expected that 45% of all the data traffic will be carried by the 5G networks. And as you can see, it means that the growth of the data traffic in the 5G networks is going to grow exponentially. And the reason is because, again, the adoption that is taking different parts of the world. It represents 1.3 times all the traffic that we have today in the 2G, 3G, and 4G networks. Just imagine this amazing size of information that is going to be transmitted on the 5G networks. Next slide, please. Now, we have been talking, and I'm sure that you are familiar with all these concepts. What is a 5G? It's a unified and more capable air interface. The 3 pillars that we can see in the left-hand side, basically this broadband, more data rates, the mission-critical services, low latency, and the massive Internet of Things, the possibility to connect a lot of things. Now, what do we need in order to achieve that? Big, very big highways, meaning a huge amount of spectrum. And for that reason, in order to have a good deployments of the 5G technology, we need, for practical purposes, every single spectrum that we can think of. And as an example, we're talking about low bands, mid bands, high bands, and we are talking about also licensed, share, unlicensed, whatever is available. We need to combine all this using obviously different techniques in order to be able to achieve a huge amount of spectrum. It is estimated for a good deployment of 5G, we need around 400 megahertz of spectrum. With 100, we can have a decent, a good deployment. But if we have like a 10, for example, 10 megahertz, is going to be very, very difficult, very challenging to have a good 5G deployment. With good, I mean with all these experience that we are positioning, like at the gigabit per second data rates and so on. So the spectrum is the most important part for a good and 5G deployment. And all these deployments will have a diverse manners to be offered. No? We can have in the street, we can have in a campus, we can have in the industry, wherever you think, we will be able to have all this. In the bottom of this slide, you can see basically what is the advantage, what is the promise of 5G. I will not go into much detail, just because you will see a lot of these numbers through this presentation. Now, the next slide, please. Okay. What is going to be the impact? The impact of 5G technologies is going to be huge, in the order of 13.2 trillion US dollars. And as you can see, this amount of money, it represents more than the internal product of a lot of countries. So it's going to be a huge, big, very, very big impact. And that is going to touch basically every single industry: manufacturing, transportation, healthcare, agriculture, energy, you name it. Whatever we are thinking is going to be impacted from 5G. Next slide, please. And also, what is the global economy output expected for 2035? The year 2035 is going to be about 5 trillion US dollars. That is how this technology is going to enable different sectors of the economy. And as you can see, basically the oil refineries, manufacturing, construction, a lot of things that are going to be impacted. In the lower right-hand side of this slide, you can see the breakdown of all these 5 trillion, that basically manufacturing is the one that is going to have the most impact of 5G. Next slide, please. And this is just an example where you can see why manufacturing is going to be one of the industries with all this impact. In one campus, in one factory, we can see, for practical purposes, the 3 pillars of 5G. For example, the mobile broadband, huge data rates, big data rates, because of the applications that we are facing, computer vision, that in order to have good quality HD, we will require, because of the number, also the number of cameras connected at the same time, the bandwidth is going to be the bandwidth required is going to be very big, and that is why this is going to be leveraged by the 5G technologies. It will be very common to have all the cameras in the helmets that a lot of people use in these factories, or are using a PDA or a smartphone, something that is going to keep track inside this factory. When we talk about the ultra reliable low latency technologies, is basically what do we need to do in order to have these very fast near to zero delays, is because just think on the industrial robot, when they are putting all the different components on the line of production, and then every single company needs to be in a given place at the very right time. Just a small delay may cause that component is going to be in a different location, and obviously it doesn't work. And the massive IoT is a possibility to have a zillion things connected at the very same time. 5G is expected to connect around 1 million devices, things, in 1 square kilometer. So a lot of things that are going to be connected at the same time. And next slide, please. And this is just a comment with regards to education. Because of the pandemic that we are facing at this time, the education is a good example on how this is 5G is going to impact all these our lives. So most of the kids are taking classes remotely. So 5G is going to be is going to demonstrate all this ability because not because one single student is going to need gigabit per second data rates, but if we think in a university, in a campus where we have a lot of students developing, for example, virtual reality, that we will require a huge amount of spectrum, then 5G is going to play a very important role. Next slide, please. And finally, we think that 5G will be as revolutionary as electricity. This is something that in the next few years, we will just have for granted that 5G is already there because of these data rates. And with 5G, we are living in a golden year of telecommunications. With that, I complete my presentation. I'm reading here that Milene is already connected. We were able to fix all these technical difficulties. I'm very glad with that. But before I'm passing the floor to Milene, I'm going to ask, we will present a few videos. So please, we will go on this first video, Breaking Through Technologies, where we are going to present to introduce the 5G technologies. So if you can please run the first video.
So my first question, at a party, how would you explain 5G to someone?
The one sentence answer is, it's a unified connectivity fabric that connects everything and everyone to each other. The way we have used wireless over the last 30 years or so, it was just people talking to each other. The notion of a voice call was the bread and butter of everything that we did.
And we've since moved from voice to more complex data, right?
Most of the communication happens to be data communications. You're watching a video, you're downloading something, texting each other, or you're in a video conference call. That was one of the reasons why the whole notion of 5G even began. The idea that it's not just people communicating with each other, but what if things communicate with themselves, with each other, and with humans around them?
So you'd need a totally different network for something like that. I always just thought this would be like shifting gears in a car, you know, like going from first to second.
A better way to think about it is that the engine that we are designing doesn't go just in a car. It can go into any kind of a vehicle out there. There are really 3 stages to it: early research and development, standards, and commercialization, which is the commercial release of 5G.
And what should we tell people about that release?
5G technology is being designed for the next generation of use cases and the idea that we can truly make a difference.
Thanks, Durga.
Well, as you can see, this was the interesting video introducing basically what is 5G, trying to do this in a easy way. The next video is going to show the 5G low latency features, and it's basically all these mission critical apps like remote robotic surgery, autonomous car. So let's see this second video, please.
What's the biggest thing we'll notice about 5G?
So I think the biggest thing is the massive data rates and the low latency. We are going to have a capacity going all the way up to like 5 gigabits per second on day one.
Can you tell me more about latency?
Look at it as like 2 people talking to each other. You're both taking turns talking, and you can talk, pause and wait for like 5 minutes for acknowledgement, or you can talk, pause and wait for 1 minute. You can imagine the smaller and smaller we make these intervals, we increase communication between 2 people.
Got it. Latency is gap time, and if there's less gap time, then communication happens faster. Why does that matter?
Think about mission critical applications like remote robotic surgeries. How quickly you can respond is extremely important, because that could be a life and death scenario. Or autonomous cars. Because if you are detecting a collision and you need to send that to the car behind you, it's extremely important that message gets to that place. There's no point telling you to avoid a collision after the collision has happened.
What's it feel like now that you're starting to see this in the world?
One of the cool things about working on technologies in Qualcomm is you cannot say hello to a stranger without them potentially owning something that you have developed. They say, oh, look what my phone can do. And you feel so good saying, yes, yes, I know exactly why it does that and why it can do that. And I think that's a great feeling.
Thanks, Vinitha.
Well, it was an interesting video trying to demonstrate how in our day-to-day we are going to have this type of benefits from 5G. And the last video that I want to present is the next one that talks about the importance of the millimeter wave on 5G. This is called the 5G millimeter wave. And let's please see this video.
So before 5G, phones always used the same low part of the spectrum, right? Then what happened?
Then we have the high bands, which have never been used for cellular communication before. These are known as the millimeter wave bands.
That's interesting. Why were they never used until 5G?
These bands, the amount of bandwidth is extremely high, but the propagation is not very good. So you have to have much more closer cell sites to the user. It allows us to be far more precise in terms of transmitting to a given user.
More precise?
Think of the difference between a flashlight, which kind of floods everyone in the room, versus a laser pointer, which can pinpoint a given user. But because the beam width is so small, there can be a complete blockage. If the user is walking past a light pole, that light pole can completely block that specific beam. So there is a beam that's tracking the user, and then if that doesn't work out, the user immediately switches to a different beam. We call this adaptive beam switching. The user can always switch back and forth between multiple beams. I walk around with it, I drive with it, and I don't care whether I'm close to the base station or not. That's when we knew, okay, there is some potential now. Now we can do something with it.
You didn't celebrate or anything?
We very rarely pause and celebrate the fact that we've solved a challenge. Maybe we should do that a little more.
Thank you, Durga.
I really like this video because not only shows in a, let me say, easy way how the millimeter waves work, but also that we were able to solve this major challenge that we had been dealing with for the past few years. Well, now I understand that my colleague Mileni is ready to give this second part. Thank you very much, Mileni, which is in our Brazilian office out of Brasilia. Now she's going to give this second part of the presentation. Thank you very much, and Mileni, the floor is yours.
Thank you, Hector. Okay, thank you for the opportunity to talk more about ITS. So I'm going to go a little deeper than what Hector had a chance to present. The C-V2X technology is in intelligent transportation system and technology, and this is what I'm going to talk about. So next slide, please. Okay, first, this is how Qualcomm sees the connected world. So we won't have just one technology to make it possible. We do have the 5G, but also with 5G we'll have the LTE and the automotive technologies, the Wi-Fi 6E, and Bluetooth, and many others, all working together to make the world connected. And this presentation, we're going to talk specifically about the automotive part of this world. So next slide, please. And first, I'm going to take this chance to introduce how Qualcomm is part of this automotive market. And we have a long way working on that since 2002, and nowadays, and with the C-V2X towards the autonomous cars. And we had the chance to touch many parts of the automotive technologies, not only the connection part, the connectivity part of it. So you can move to the next slide. Okay, so Qualcomm automotive market, and now we have reached around 100 million vehicles with Qualcomm technology modems, and with 18 leading automakers. We are leaders in Bluetooth technology, in telematics, and designs for premium infotainment. So the chance that we have Qualcomm technology in our cars is really high, considering our portfolio. And we work with the major automakers in the world with our solutions. Okay, and in this slide you can see some of them. You can change. You can go to the next one. Okay, so about the connected car, this is 20 years. What we have now is the result of 20 years of advances and delivering cellular technology in the automotive industry, and now we started back there in the beginning of the previous decade, then 2000, and now we are moving toward the 5G and with the C-V2X. C-V2X is starting the release 14 of 3GPP and with the LTE connection, but now it keeps improving the next releases. Okay, so you can change to the next slide, please. And why this technology is so important? We had big numbers here, and we have more than 1,350,000 deaths caused in roads worldwide. So these fatalities, many of them can be avoided with the advance of technologies to be used in the traffic. And besides this major problem, we also have economic impacts and the impacts in the environment. And we have the numbers here about how the economy can be impacted with the congestion. This is an example in the United States where the transport inefficiency can cost $305 billion in US alone, just due to congestion and all the time that it is spent in congestions. And you can click in the slide because we have the information about the fatalities in Latin America. So this is a huge number. And so the improve of the intelligent transportation system technologies will have impact on these numbers. They will decrease heavily. So this is why we should take a look and understand how important it is to have this kind of technology implemented as soon as we can. You can change the slide, please. So how this technology works? The C-V2X. So it stands for Cellular Vehicle to X, which is anything. So it can be a person through a mobile device. This X can be infrastructure, and this X can be another car. So and it can be the network. And so in this picture, in this figure that you can see, we see the representation of this kind of communication. So we see the vehicle in the middle talking with the light, with the infrastructure, and if there is a problem in the road, they can send this sign directly to the car, and also information about the pedestrian that is coming over or another car that is having hazard behavior. And all this communication is going on without the need of too much interference from the driver, and many times without the interference of the driver, because the communication is between the things, the devices. Okay, so you can change the slide. And here's how the communication works. It can be through the network, so the cellular network that we have, but it can also, and the safety communication is going to happen in this part in the 5.9 spectrum, 5.9 gigahertz spectrum band. And in this part, we have this direct communication in 5.9. And we have the car talking to another car, vehicle to vehicle. We have the car talking to the infrastructure. And you have the car talking to the person through his device. And this direct communication is responsible for the safety part, where we make the better use of the low latency possible with this technology. And so when something is about to happen, the cars can communicate quick enough to avoid an accident or a minor problem, or even worse, a fatality. But the network is still needed. The network is important for the coverage of the area, because the communication, you can have communication from the authorities about a problem that's going ahead. It can come, you can have a broadcast using the network, okay? And this would happen in the regular network bands, the cellular bands that we have, the mobile bands. You can go to the next slide, please. And so this is a quick summary, because we wouldn't have enough time to go in detail for all the advantages of C-V2X, but you have the chance to have a understanding of the benefits that it can bring. But I would like to highlight that it's designed to work on the harmonized ITS 5.9 spectrum for safety applications. And it's a modern technology with superior radio performances. So the communication takes advance on the low latency. So it starts happening. We're gonna see in a video that starts happening before enough that the cars can take action to avoid a problem. And it's expected to be ready for commercial deployment in 2020. So this year, we do have commercial deployments. There's a video about one in Virginia, United States, and it was announced in the beginning of this year. But it's now in September, it was announced that it's already being deployed, and which is focused on road workers and drivers for their safety. And it's better to understand how it works in the quick video, but it's a really nice implementation, and the results, we will be able to see the impact in a specific parts of the problems that we have in traffic nowadays. And can you go back to the slides, please? I think it's dropped. There, thank you. Okay, so this is just one example among many other trials that are happening all over the world. But I brought one of them just to have an idea that we already have it. And the only V2X technology with a clear and forward compatible evolution to 5G. And this is really important, because C-V2X is able to combine its benefits with the benefits of 5G that Hector talked about. So that for the automotive part, this is really important to take advantage and the mobile broadband, the low latency, the massive IoT. And so the benefits that we have in 5G, we're going to be able to have with cellular V2X and in 5G technology. So this is really, really important. Okay, next slide, please. Okay, so the global presence, the C-V2X, we have support. This technology has the support of many key ecosystem players. We have small list of them in this slide. They are all associates of the 5GAA, which is a automotive association that works on spreading the information, advocating, and supporting the 5G, the C-V2X advances in the world. And here we have a picture of many trials and demos that are happening. And it's important that to highlight that among these partners, we have operators, manufacturers, the roadside units manufacturers, the devices in the car manufacturers. So the ecosystem is ready. We do have the Qualcomm launched in 2017 the chipset for the cars, and now more recently we now have to the roadside units as well, and we starting to have the deployment, and so that's why we should consider supporting the advance and implementation of the technology. The next slide, please. And so this is a strong momentum for C-V2X. And we, the 5GAA Association, the association that I just mentioned in the previous slide, has done a great job with this and all those associates. And here in this timeline, we can see the chipset that was launched by Qualcomm in 2017 for the cars. The modem, car modem that already has the C-V2X technology embedded. And here, more recently, in 2020, the announcement of the Virginia implementation that I just mentioned. But in January was just the announcement that it would happen, but now it is happening. In September, the deployment was announced. Okay. And the standards are also in its final definitions, and so we do have the C-V2X really moving forward nowadays. You can change this line, please. So these what we must consider: the 5.9 gigahertz bands for C-V2X technology. And in Brazil, we just had the regulation updated, and Brazil does have the 70 megahertz for ITS allocated, which is really great news. And the last 30 megahertz are for safety applications. And you can see that we do have this block in the beginning with a guard band and saved for protection of the ITS. But the 70 megahertz, the recommendation is to be allocated for ITS. And this is a really important topic. It was an agenda item in ITU and the International Telecommunications Union in the previous cycle. And this resulted in two documents, one addressing the technology part and the other one addressing the spectrum allocation, aiming for harmonization. And the recommendation, the result was for 5.9 gigahertz for ITS. And this topic is still very relevant in the ITU. And they continue working on more in other documents such as the CAV, connected automotive vehicles, and handbooks related to automotive technologies. And not only Brazil is in the region is a country that has taken this decision, but in the world you can have other examples such as Korea, South Korea, and Australia. And FCC is working on updating their regulation. And so this is the main message that I would like to take to you, which is considering this recommendation and aligning with what's happening in the world with 5.9 gigahertz band for ITS technologies. Please, next slide. And I thank you for the opportunity. And I would like to share quick videos just to emphasize some of these messages that I brought to you. The first one, okay, which is a demonstration in Las Vegas. And then you can see some of the features of the C-V2X.
The following is a showcase of live C-V2X direct communication interoperability, in which vehicles from different automakers communicate with road infrastructure, pedestrians, and directly with each other without the involvement of a cellular network. Here we present 3 road safety use cases featuring this breakthrough technology. Maneuver negotiation involves a 4-way stop where vehicles use C-V2X to communicate their location and speed, allowing them to negotiate the order of their intersection crossing. All of this happens seamlessly and without the need for driver input. Maneuver negotiation is an example of cooperative driving that can be extended to autonomous and connected vehicles and is the type of service that will be made even better with 5G. Pedestrian crossing warning is designed to alert drivers of pedestrians crossing the road over long-range and non-line-of-sight conditions. Intersection movement assist is designed to help the driver who cannot see cross-traffic at an intersection due to obstructions like buildings or trees. As the vehicle approaches the intersection, it gets a warning that there is a vehicle in its path about to cross. Thanks to the extended range of C-V2X, especially in this non-line-of-sight scenario, the driver gets a warning well in advance and is able to stop in time to avoid a serious accident. This showcase exhibits some of the benefits of C-V2X real-time direct communications for road safety while working across vehicles from multiple automotive brands. Audi AG, Ducati, Ford Motor Company, and Qualcomm Technologies are proud to be driving C-V2X along the path to 5G, working to improve automotive safety, automated driving, and traffic efficiency around the world.
Okay, and the second video is about the Virginia implementation and where you can understand what is the main objective. It's the safety of the road workers and the drivers, and using C-V2X technology to guarantee that.
Transportation, when roads and infrastructure can offer a safer solution for drivers and other road users. In partnership with the industry leaders and transportation agencies, we're excited to deploy C-V2X in Northern Virginia and offer a look at the emergence of safer roadways. Work zone roadside safety messages offer a greater awareness for the driver, who can receive an initial advisory message communicated over a cellular network, and subsequent work zone safety messages via low-latency direct C-V2X. Vulnerable maintenance and construction personnel in work zones benefit from C-V2X as well. In the event that a worker wearing a smart vest is near the boundaries of their work zone as a vehicle approaches, C-V2X provides warnings to the worker and nearby driver. Today's vehicles use cellular networks to provide traffic signal countdowns and speed recommendations to enhance safety and reduce congestion. With C-V2X, the car and its driver will receive road data faster and more accurately. Currently, Green Light Optimized Speed Advisory recommends ideal traveling speeds through intersections. By deploying dedicated infrastructure to send and receive other traffic variables in the future, such as vehicle queue ahead or direct C-V2X, speed recommendations will be further optimized. While today's traffic signal countdown predicts the next green light, pop-up messages and audible alerts enabled by low-latency direct C-V2X can enhance traffic signal information to warn of an impending red light violation. Start on the Virginia Smart Road Test Bed at VTTI for testing and final tuning. These advancements will arrive later this year on Northern Virginia Public Road and beyond. Virginia Department of Transportation, Audi, American Tower, Traffic Technology Services, Virginia Tech Transportation Institute, and Qualcomm Technologies are excited to establish the C-V2X ecosystem and contribute to the safety and efficiency of today's roadways.
Okay, and the last video is to give you an idea of how the Qualcomm technologies is paving the way towards autonomous vehicles. So thank you.
Well, thank you. Thank you, everybody, for your attention. And also, we want to thank Forum Global for the opportunity. It was a very good organization. And well, just to thank everybody for attending this session. Thank you very much.
Yes, thank you for the opportunity. It was really nice to be back to the Latin Spectrum Management Forum this year.
Bye now.